Our whole world runs on this massive, interconnected digital network. And as it gets smarter and more flexible, it's also creating all these new shadowy corners for really dangerous bugs to hide. So, how in the world do you catch a ghost in the machine? Well, today we're going to meet a new kind of digital detective that was built to do exactly that. To really get this, let's just dive right into a real-world digital heist. It was so clever, so subtle, that all of our best security systems were looking in completely the wrong places, and it allowed just one attacker to bring an entire network crashing down. Okay, so here's how this crazy attack actually worked. First, the network's brain, called the controller, sets up a totally normal rule to check out certain kinds of traffic. Simple enough. But then, an attacker starts flooding the network with data packets that look almost right, but are actually broken in a very specific, clever way. Now, the network's muscle, this super fast switch, it was never programmed to spot this particular kind of mistake, so it just passes all that junk right along. And the final step? The brain just gets completely buried under all this garbage data, and the whole system crashes. And I gotta say, this isn't just a theory. It's a real vulnerability that was found by the tool we're talking about today. So you might be asking, how is an attack like that even possible? Well, to get it, we need to understand how these modern, advanced networks are put together. They're nothing like the old, rigid systems we used to have. I think the best way to picture it is to think about a city's road system, right? You've got the roads themselves, the brawn, with all the cars and trucks actually moving around, and then you have a central traffic command center, the brains, making all the rules in real time about where everything should go. In the networking world, this separation has a name. They call it decoupling. The brains, that's what's known as the control plane. It's a centralized controller making all the big picture decisions. And the brawn is the data plane. That's the actual hardware, the switches and routers, doing all the heavy lifting and moving data at insane speeds. Now, the language they use to talk to each other, this is really the key. There's a special language called P4 that lets the brains actually program the brawn on the fly. Teach it new tricks. This is what makes the whole network so incredibly flexible. But as we just saw, it also opens up the door to some seriously sneaky new problems. So what was the critical mistake in how we were thinking about security? Why were we missing vulnerabilities like the one we just looked at? Well, it turns out we had a massive, massive blind spot. So here's the core of the problem. Our old security tools were completely siloed. We had tools to test the brains, and then we had totally separate tools to test the brawn. It was like having one safety inspector for the city's traffic command center and a completely different inspector checking the pavement on the roads. Nobody was actually checking the orders being sent from the command center down to the streets. That's where the bugs were hiding. And this number, wow, this really puts it all into perspective. When researchers did a deep dive on known network bugs, they found that more than 1 in 5 of them, over 20%, existed in this exact blind spot. These weren't bugs in just the brains or just the brawn. Nope. They were bugs that only showed up in the conversation between them when a very specific rule from the brain met a very specific data packet from the brawn. All right, so this is where our digital detective finally enters the story. A brand new tool designed specifically to hunt for bugs in that blind spot, to see the entire city grid all at once. It's called CHIMERA, and it's named after that mythical beast that was made of different animals. The name is just perfect, because CHIMERA is what's known as a hybrid fuzzer, which is a fancy way of saying it's a tool that automatically throws tons of unexpected data at a system to see what breaks. It combines the testing for both the brains and the brawn into one single approach, all to hunt for these hybrid bugs. And the core idea behind it is so simple, but it's also revolutionary. Instead of checking all the parts in isolation, it tests the entire system as a whole, all at the same time. It's like sending a suspicious-looking car down the road at the exact same moment it tells the traffic command center to create a bizarre new detour, just to see if those two things combined cause a massive pileup. So how does this thing actually work? How does it manage to craft the perfect storm of inputs to find these bugs that are buried so deep? Well, it has two really, really clever techniques. First off, it doesn't just throw random garbage data at the network. It uses a technique called parser-aware packet mutation. Basically, it reads the network's own rulebook first, and then it crafts a malicious data packet that it knows will look legitimate. It's like creating a forged ID that is so perfect it's guaranteed to get past the bouncer's initial check. Okay, so once it has that perfect forged ID, CHIMERA then figures out the exact right person to show it to. This next technique, Header-guided rule generation looks at that forged packet and then generates the one specific rule for the brains that will activate a hidden vulnerable pathway. So it's not just having the perfect disguise, it's also knowing the one security guard who will wave you right through if you show it to them. So what were the results? Well, they're pretty incredible. In its testing, CHIMERA found 7 brand new bugs in software that everyone thought was totally mature and stable. 3 of them were critical security flaws, including that denial of service attack we started with. But what's really important here is that 2 of them were true cross-plane bugs, those ghosts that were just completely invisible to the old way of testing. And this is the number that really made me sit up and take notice. By testing both planes at once with these really intelligent techniques, CHIMERA found bugs 3.5 times more effectively than the previous state-of-the-art tools. So it's not just about finding bugs that were invisible before, it's about finding all bugs much, much faster. Okay, so let's zoom out for a second and talk about why this really matters. Because this isn't just about a few bugs in one piece of software. This points to a fundamental shift in how we need to approach securing our future. I think the biggest takeaway here is this. The digital infrastructure that powers our entire world is becoming less like a rigid machine and more like a complex living organism. And if that's true, then our security can't afford to have blind spots anymore. Our digital detectives have to evolve to be just as smart and as holistic as the systems they're trying to protect. And that brings us to the final, really critical question. The story of CHIMERA is this powerful proof of concept. It shows us that we can build smarter detectives for our smarter world. The challenge now is making sure that this holistic way of thinking becomes the standard, not the exception, as we build whatever comes next.